So here we are, and we are about to discuss about the queuing theory and traffic flow analysis. So queuing theory and traffic flow analysis is the formation of traffic queues during congested periods is a source of considerable time delay and results in a loss of highway performance. It is essential in traffic analysis the one develop a clear understanding of the characteristics of queue formation and dissipation along with mathematical formations that can predict queuing related elements. So, the dimensions of queuing models. Its purpose is to provide a means to estimate important measures of highway performance, including vehicles delay and traffic queue lengths, and it is also derived from underlying assumptions regarding arrival patterns, departure characteristics, and queue discipline. And it also requires assumptions of relating to vehicle departure and characteristics. Identified by three alphanumerical values: arrival rate assumption, departure rate assumption, and number of departure channels. So D/D/1 queuing. So the case of deterministic arrivals and departure with one departure channel. So or D/D/1 queue is an excellent starting point in understanding queuing models because of its simplicity. So we have an example, and vehicles arrive at an entrance to a recreational park, etc., etc. So here are the example questions. Solutions. Here it is. And it is. And we are about to discuss the M/D/1 queuing. The assumptions of exponentially times between the arrivals of successive vehicles or Poisson arrivals will, in some cases, give a more realistic representation of traffic flow than the assumptions of uniformly distributed arrival times. Therefore, the M/D/1 queue exponentially distributed arrivals, deterministic departures, and one departure channel has some important applications within the traffic analysis field, although a graphical solutions to an M/D/1 queue is a difficult mathematical solution is straightforward. And here's an example of the formula defining a new term or traffic intensity for the ratio of average arrival to departure rates as a P is equal to the traffic intensity or unitless, and the variable here is equal to average arrival rate in vehicles per unit time, and the U is equal to average departure rate in vehicles per unit time. So here is an example of the M/D/1 queuing. Consider the entrance to the recreational park described at DD1 queuing sample, etc., etc., etc. So here is the solution. You can find the solution here and compute it by yourself to make it to or determine it as right. And MM1 or M/M/1 queuing is a queuing model that assumes one departure and exponentially distributed departure times in addition to exponentially distributed arrival times, or M/M/1 queue is applicable in some traffic applications. Here's an formula. So a variable of is equal to the average of length of queue in vehicles. So here's the formula. /W is equal to the average waiting time in the queue in unit time per vehicle. So /T is equal to the average time spent in the system /W plus 1 over U in unit time per vehicle and other terms as defined previously. Here is an example again, and solution. So MMN or M/M/N queuing a more general formation of the M slash M slash 1. Q is the M slash M slash NQ, where N is the total number of departure channels. Here's the example formula. And the conversions, again and again, conversions of the formula, an example, for you to understand it. And so on. As I've said, queuing, theory, and traffic flow analysis is the formation of traffic queues during congested periods is a source of considerable time delay and results in a loss of highway performance. So it is essential in traffic analysis that one develop a clear understanding of the characteristics of queue formation and dissipation along the mathematical formulations that can predict queuing related elements. So that's all. Thank you.